Hi guys, welcome back to the next video. In this video, we are going to talk about very important topic over here. We're going to talk about the difference between why we need to really have a persistence store. Persistence volume when you already have NFS. So the questions I get a lot from people is that we already have a NFS volume which is actually doing the persistence in terms of accessing your application, working with your application flawlessly in terms of transmitting the data from and through. Why do we need another, persistent volume concept over here as part of Kubernetes? Well, that is what we're going to see in this architecture diagram. What is the difference between the volume plugin NFS and the persistent volume? Now, in the previous demos, you must have seen the beautiful thing about NFS, where in which you can hold the data on any worker, which it creates randomly, and that data will be available even after you delete the pod. Still, the data will be retrieved from your NFS drive, right? So if NFS does everything, what the persistent volume, which we're going to see from next video onwards, is going to bring in new. So that's what we are going to discuss about. The first thing is about the flexibility and portability. Persistent volume can be provisioned with various storage solutions, including a cloud storage provider, a NAS or network attached storage, or local storage, or even NFS as well. So it allows a greater flexibility and portability in terms of choosing your storage solution that suits the best need for you. In terms of NFS volume, on the other hand, relies on NFS service or NFS server for your storage, which may not be ideal for all the situations. So if I don't have a separate option here, so I have to stick with NFS as the only option. But in terms of persistent volume, I have, as I told you, I can use it on a NAS, I can use it on a local storage, or I can use it even with a block storage from AWS or Azure or GCP. So that's one thing. And I can even use NFS as the persistent volume. So that is always another option which you have in terms of persistent volume. The next item which is going to differentiate between persistent volume and your NFS is that is dynamic provisioning. Kubernetes supports dynamic provisioning of a persistent volume using storage classes, allowing storage resources to be automatically provisioned based on pod's requirement. This simplifies the management of storing resources and ensuring that the pod have access to the storage that it needs or when it needs. So if you can see in this architecture, you can see that for primarily it is assigned 10 GB, and then now it's assigned 20 GB after a while, because we have such a dynamic allocation possible through storage classes. That's another definition which you need to do, or manifest we need to do. But that helps you to dynamically allocate your storage requirements based on the pod's needs. In terms of working with NFS, you're going to have this problem of a static allocation is the only thing which you're going to have, because you must have predefined how much amount of space you are going to dedicate for your NFS drive. And you cannot actually assign some space to your pod. You have to assign all the space to your pod. And it kind of exposes everything to the pod. So that's one difference which is going to happen here when you segregate them both. Awesome. Let's go to the next one, which is integration with Kubernetes API. Now, this is going to be a game changer for you. When you look at this architecture, persistent volume is directly integrated to your API of Kubernetes that can be managed by the standard Kubernetes tools and commands. This provides a consistent interface for managing storage resources alongside of other Kubernetes objects. While NFS volume can be mounted into a Kubernetes pod that are managed externally to Kubernetes and many require special tools or process to process your or managing or monitoring the NFS service needs to be a separate process itself to do that. But as part of the your persistent volume, it's all going to be part of your Kubernetes, and it's going to be internal for you to monitor it. There may be a situation where we will be configuring your persistent volume to use NFS volume internally. In that time, you may be asking question, then there is a whole overhead of NFS volume to be monitored and maintained, right? But that's just an option. So other than this option, you can go for a cloud block devices, or you can go for a local storage, or you can go for any cloud local storage as well. So likewise, it's giving you multiple options, where here there's no much option over here, except for this one straight option of NFS. The next point we are going to talk about is granular control. Granular control means more fine-defined control can be offered in terms of your persistent volume. So what kind of granular control? Persistent volume offers granular control over storage resources, including access modes, storage classes, volume reclaim policies. So these are some things which you will understand when we go through the next video and try to understand, because these are some parameters which is part of your persistence volume definition in terms of your manifest. These allows you to fine-tune the storage configuration to match the specific requirement of each pod. In terms of NFS volume, not much. You have a read and write option. Either you go for a read and write option, or you go for a read-only option. So these are the two major options which you have in here, which separates you from the level of granularity in terms of controlling your data, in terms of both PVN as well as your NFS. In terms of performance and scalability, depending on the underlying storage system, persistent volume may offer better performance and scalability than of the NFS volume, especially in distributed and high performance computing environment, or HPC. In terms of NFS volume, it has limitation in terms of performance and scalability, particularly in large scale deployments or scenarios where high input output requirements are mandatory. So these are some of the examples which will enable you to understand the difference between using or going for a persistent volume or going for NFS volume. So you can clearly see that the persistent volume stands out, and where it stands out is basically it can also include the NFS volume as part of it, and also it provides you other services to integrate it with itself. And it has the very good control over what kind of resources you are assigning towards your pods. So likewise, these are some of the details. If you have any questions, please do reach out to me on the question sections. I'll see you on the next video, guys.